Our task for this example will be to visualize crash test data. To find the data, go to Help and then Sample Data Library. Under Sample Data Library, you will find a catalog of jump data tables that you can use. The data table we are looking for is cars.jmp. Double-click it to open it. Since I have the data table already open, we can start our first visualization. We want to visualize the make of car used, and we want to understand which cars were used for the crash tests. Since this is categorical, we can make a bar graph from it. Bar graphs are found under Graph, Chart. Go ahead and click it. To make the bar graph, you can double-click on the variable of interest, which for this example will be make of car, and then click OK. Now we have our bar graph. You'll notice right now that all the bars represent a count of each car we have sampled. There's more we can do. Go to the red arrow and select Label Options. Under Label Options, we can label by the percent with the second option. This will show us the percent of each car that was in the sample we obtained. We can change it and give it the count by go to Label by Value. Label by Value will show us a count over each of the bars. Notice how the count axis on the left actually corresponds to each of the counts for each of the make of cars. The numbers line up with the count axis. There is more we can do though. A bar graph might not be the best way to explain this data. We can also display this data with a Pareto plot. Let's go ahead and close this out. A Pareto plot can be found under Analyze, Quality and Process, and Pareto plot. Go ahead and click on Pareto plot. Now, you can double-click your variable of interest, which is make for this example, and then click OK to make the Pareto plot. With the Pareto plot, we have actually put all the models in order from most common to least common. Notice how we had the most samples of Chevrolet, Ford, and Nissan, and the least samples of Saturn, Volvo, and Yogu. The line over the Pareto plot shows both a cumulative measure of the count and a cumulative measure of the percentage. It's very useful for interpretation. There are more options we can add to this. We can go to the red arrow again and select to add the count. This shows us how many we sampled. For this problem, we have sampled 352 cars. We can also go back to the red arrow and try out many of the options available to us. Feel free to try these at your own leisure and make your own Pareto plot. Another way to customize your Pareto plot is by giving it its own title. Let's go ahead and double-click on Pareto plot and change the title to the Pareto plot of cars used in crash tests. Now we have our own title. Make sure your title actually represents the data that you are displaying. Our Pareto plot displays the most commonly used to least commonly used cars. Let's go ahead and close this out. For this next visualization, let's examine what kind of protection was used in the cars. This can be done with a pie chart found under Graph and go back to Chart. In the dialog box, we'll have the option to select our data by double-clicking it again and then changing bar chart to pie chart. Go ahead and click OK to make your pie chart. Now you'll notice we have a pie chart that displays the type of protection used. Let's go ahead and add our label options again by adding them as a percent. Now we have the percent. We can start with some small changes to our pie chart by pulling out on the sides to extend the pie chart. Pull a little bit further and make it just the way you want it. This is just the start of customizing our pie chart. Always interpret your data. You'll notice that manual belts was the most common group, with over 50% in our tests, where driver and passenger airbags was the least common, with 1.1%. There are a lot more options you can choose from to customize your pie chart. One customization we should never forget is customizing the title. Let's go ahead and customize it to a title that will convey the knowledge that is inside the pie chart. This is a pie chart of protection used in crash tests. Now people will understand the information we are trying to convey. Making a graphical display is only half the work. Interpreting it is always the other half. For this last example, We've been tasked with looking at the relationship between size and protection. Are the two variables independent of each other, or are they not independent? To figure this out, we will have to look at a mosaic plot, which does bivariate categorical data, found under Analyze Fit Y by X. So go ahead and let's see if the size of the car can explain the protection that a car has in it. This will make our mosaic plot where X is the size and Y is protection. With our mosaic plot displayed, you'll notice that both variables are contained inside. This is a bivariate display of size and protection. This green category represents driver and passenger airbag and is so small you can barely see it between the red and the blue on the right. Clicking on the right axis highlights all the cars that fit into that category within the size. You'll notice that there seems to be some sort of a relationship between the size of the car and the protection used in that car. The following four sizes of cars primarily use only manual belts, and the following four sizes of cars have a wide array of what they use for protection. This would indicate to us some sort of association between these two variables, where size of car might tell you something about the protection used in that car. We can change the title of our mosaic plot or leave it. This visualization is ready to go.